नमस्कार, मैं प्रोफेसर अवनीश कुमार बुंदेलखंड विश्वविद्यालय झांसी के डिपार्टमेंट ऑफ मैथमेटिकल साइंसेज एंड कंप्यूटर एप्लीकेशंस में प्रोफेसर ऑफ मैथमेटिक्स के पद पर कार्यरत हूँ। इसके पूर्व में वैज्ञानिक तकनीकी शब्दावली आयोग, शिक्षा मंत्रालय भारत सरकार में अध्यक्ष के रूप में भी कार्य कर चुका हूँ और इसी के साथ एक अतिरिक्त प्रभार के रूप में केंद्रीय हिंदी निदेशालय, शिक्षा मंत्रालय भारत सरकार में निदेशक के पद पर भी कार्य कर चुका हूँ। साथियों, आज इस लेक्चर में मैं आपको एक भारत के एक बहुत ही विशिष्ट ज्ञान देने वाले मैथमेटिशियन श्रीधराचार्य के विषय में चर्चा करूंगा। श्रीधराचार्य पाटिगणिता ऑन अर्थमेटिक एंड मेंसुरेशन। आज के इस लेक्चर में मैं श्रीधराचार्य के विषय में ब्रीफली समराइज करते हुए श्रीधराचार्य द्वारा रचित पाटिगणित के विषय में चर्चा करूंगा। श्रीधराचार्य के पाटिगणित में मुख्य रूप से अर्थमेटिक और मेंसुरेशन पे काम किया गया है। इन दोनों विषयों को अपने इस आज के लेक्चर में समाहित करते हुए अंत में एक कंक्लूडिंग रिमार्क प्रस्तुत करूंगा। फर्स्ट ऑफ ऑल, वी पे होमेज टू द Sridharacharya, one of the renowned Indian mathematician who has worked for the society, who has worked for the mathematics. He visualized that society need mathematics. That's why he has given the basics of mathematics, and entire mathematics given by Sridharacharya is for the society. He has worked on arithmetic, he has worked on Vyavaharic mathematics, he has worked on algebra, he has worked on mensuration. So first, we pay homage to Sridharacharya, one of the most renowned Indian mathematician. Patiganita by Sridharacharya. Sridharacharya Virichatam Patiganitam. This is the content of the book of the Patiganita that has been written by the Sridharacharya or presented by the Sridharacharya for the society. When we see the content of this book, we find that there is initially the homage and introduction of the book. Then it contains the basic definitions like names of notional places, table of money measures, table of weights, table of measures of capacity, table of linear measures, table of time measures. The second chapter is devoted to the logistic, that is called parikarma. In this parikarma, we are having the addition, subtraction, multiplication, division, squaring of the number, cubing of the number, square root, cube root, operation for fractions, reduction to fractions, rules of 3, inverse rule of 3, rule of 5, 7 and 9, barter commodities, sale of living being. The third topic that is again important for the society is based on the determination pertaining to mixture of things. In this topic, it includes the simple interest, allegation of pieces of gold, partnership, purchase and sale, meeting of two travelers, wages and payments, the cistern problem, wages paid from the commodities, combination of saviors, certain special type of problems. The next topic of the book is determination pertaining of series of arithmetic progression, series in geometric progression, series of squares, cubes and successive sums of natural numbers, series of squares and cubes of the terms of arithmetic series. Then last chapter is based on the introduction, area of quadrilateral with equal altitudes and of triangles, area of quadrilateral with unequal altitudes. and in the last, some solved examples are given in the book of the Patiganita. When we talk about Sridharacharya, it is known as Sridhara or Sridharacharya, and we expect that he lived during 18th to 19th century, although we are not having exact time, exact period of Sridharacharya. He was Indian mathematician known for two extent territories about arithmetic and practical mathematics, that is Patiganita and Patiganita Sar, and now lost territories about algebra, Bijganita. Sridharacharya was probably a Shivati Hindu. Sridhara or Sridharacharya, the period that is best known is 18th to 19th century. He was mentioned by Bhaskara II in 12th century and made apparent reference to Brahmagupta 7th century. Govind Swami 9th century quoted a passage also found in Patiganisara, and overlapping material is found in the work of Mahavira, that is 19th century, from which historian estimate Sridhara to have lived in the 18th or early 9th century. He was sometime been conflated with the other medieval Indian scholar also named Sridhara. The best known period of Sridhara is 870 to 930, who lived in Bengal, wrote the book titled Naushatika, Trishatika and Patiganita. He gave a good rule for finding the volume of a sphere, the formula for solving the quadratic equation. The Patiganita is a work on arithmetic and measurement. It deals the various operations that include elementary operations, extracting square and cube roots, fractions, 8 rules given for operation involving zero, method of summation of different arithmetic and geometric series, which were to become standard reference in later work. All three of Sridhara extant works, the partially preserved Patiganita, Ganit Sara, Essence of Mathematics, and Ganit Panchamaveshi, Mathematics in 25 verses, belong to Patiganita, but according to Bhaskara II, 1114 to 1185, he wrote at least one book on algebra, that is Bijganita. Patiganita consists of versified mathematical rule without proof and example arranged under two headings: Parikrama, basic operations, and Vyavahara, applied or procedural mathematics. The first part treats arithmetic operation including the calculation of squares, square roots, cube and cube roots for both integer, fraction, reduction of fraction and proportion. The second part presents mixture problems and various series before it breaks off in its midst of rule for plane figures. The topics of the remaining sections are ditches, brick piling, timber sawing, heaped up grain, shadows, and zero, according to the table of contents given at the beginning of the work. Sridhara composed Ganit Sara and Ganit Panchamaveshi as epitomes of a larger work which may or may not have been Patiganita. He extended Aryabhata's list 499 of names of the first 10 decimal place to 18 places. The new list was inherited by most Hindu mathematicians after him. The new list was inherited by most Hindu mathematicians after him. The topic treated by him included combination of taste, combinatorics involving the 6 tastes of bitter, sour, sweet, salty, astringent and hot. geometric progression, geometric expressions of arithmetic progressions by means of trapeziums called series figures, the problems of the 100 fowls and the cistern problem. He gave the first correct formula in India for the volume of a sphere and of a truncated cone. He used the approximation for pi, the traditional Jain value of a sphere root. He used to approximate for pi the traditional Jain value of square root of 10 as well as 22/7. Bhaskara second cites Sridharacharya's rule for quadratic equation that allows two solutions of a single equation insofar as they are positive, probably from Sridharacharya's lost work on Patiganita. He presented a method of completing the square to solve quadratic equations, sometimes called Sridhara method or the Hindu method, because the quadratic formula can be derived by completing the square for a generic quadratic equation with the symbolic coefficients. It is called Sridharacharya formula in some places. Sridhara wrote two extant mathematical treatises. The first, Patiganita, also called Bharatpati, bigger Pati, and Naushati, having 900 verses, extensively covered the practical mathematics of the time, including arithmetic and mensuration. The part of geometry concerned with calculating size, length, areas, and volumes. It is believed to have originally included 900 stanzas, but only 251 are extant, and many topics mentioned in the table of contents have been lost. The second, Patiganit Sara, also called Trishatika, having 300 verses, because it was written in 300 verses in an abridged summary of Patiganita. It discussing counting of numbers, natural numbers, zero, measures, multiplications, fraction, division, square, cube, rule of three, interest calculation, joint business or partnership, and mensuration. He also wrote a book on algebra, Bijganita, which has been lost, but some quotations remains in the work of later mathematicians. Some historians believe that Sridhara may have authored another mathematical treatise called Ganit Panchvimsi. The Sridharacharya notable works include, he gave an expression on zero. Sridhara notable works includes, he gave an exposition on the zero. He wrote, if zero is added to any number, the sum is the same number. If zero is subtracted from any number, the number remains unchanged. If zero is multiplied by any number, the product is zero. In the case of dividing a fraction, he has found out the method of multiplying the fraction by the reciprocal of the divisor. He presented a method of completing the square to solve quadratic equation, sometimes called Sridhara's methods or the Hindu method, because the quadratic formula can be derived by completing the square for a generic quadratic equation with the symbolic coefficient. It is called Sridharacharya formula in some places. When we see the work of the Sridharacharya's Patiganita deals with arithmetic and mensuration. Scholars working in the field of Hindu mathematics such as Sudhakar Dwivedi and S.B. Dikshita. Sudhakar Dwivedi in 1899 AD edited Trisatika, but this was not available in the form of manuscript. A manuscript of the work existed in the Raghunath Temple library at Jammu. The late Dr. A.N. Singh was the first discover the Sridharacharya bigger work on arithmetic and mensuration. The detail of manuscript that are available with us, manuscript numbers 3074, name of work Patiganita Tika, name of author Sridharacharya, number of leaves 157, syllables per line 44. Time of writing of the manuscript is not known. Remark, incomplete modern Kashmiri script. Name of commentator is also not known. These are the topics that covered in Patiganita, that is definition, logistic, parikarma, determination pertaining to mixture of things, mishra ka vyavhar, determining pertaining to shredi vyavhar, and determination pertaining to plane figure, kshetra vyavhar, and the last topic being incomplete. The following topics, though mentioned by the author in the list of content and totally missing from the manuscript: determination pertaining to evocation, khata vyavhar; determination pertaining to piles of bricks, city vyavhar; determination pertaining to swamp pieces of timber, karakka vyavhar; determination pertaining to heap of grain, rashi vyavhar; determination pertaining to shadow, chaya vyavhar; and the mathematics of zero, shunya vyavhar or shunya tattva. The available text of the Patiganita comprises altogether 251 verses, of which 118 contain definition and rules, and 133 contains examples. Patiganita is the name given to the branch of Hindu mathematics which deals with arithmetic and mensuration. It is believed that this subject attained an independent status sometime before the beginning of the Christian era, when arithmetic became a separate subject and geometry, which formerly belonged to a separate group of science, which the Kalpasutra came to be incorporated with it. The earliest work exclusively dealing with this subject, which has come down to us in the fragmentary manuscript known as the Baksali manuscript. Text composed about 200 AD, which was discovered in 1881 AD at Baksali, a village near the city of Peshawar in the northwest of India. In course of excavation by a farmer, this work shows beyond all doubt that by the 3rd century AD, when its text was composed, the subject of Patiganita was already in the state of maturity. It is very important to note Sridharacharya was only author who wrote 2 works dealing exclusively with arithmetic and mensuration, which the Patiganita and Patiganita Sar, abstract of Patiganita and Patiganit. Sridharacharya, having vowed to God Shiva, tell the essence of Ganita as extracted from the Patiganita composed by himself for the use of the pupil. Also, Patiganita is expressed as Bhratpati, bigger Pati or bigger work on Patiganita. Raghav Bhatta in 1493 AD, in his commentary entitled Padartha Sara on the Sridharacharya, referring 2 works of Sridharacharya, the Patiganit, it covers the logistic and determination. In logistic, that is Sankalita addition, Vyavakalita subtraction, Prihatpanna multiplication, Bhagbhara division, Varga square, Vargamula square root, Ghana cube, Ghana Mula cube root. The same operation for fraction, Kalasavarna, reduction of fraction of 6 varieties, Trishatika, rule of 3, Vyavastha Trishatika, inverse rule of 3, Pancharashika, rule of 5, Sapta Rasika, rule of 7, Navrasika, rule of 9, Banda, Pratibhanda, barter of commodities, and Jiva Vikra, sale of living being. Determination, Misraka, mixture, Shredes, Kshetra, plain figures, Khata, excavation, city, piles of bricks, Karakra, swamp, pieces of timber, Rashi, heaps or mounds of grain, Chaya, shadow, and Sunya Tattva, the mathematics of zero. The Patiganit Sara or Trisatika, the Patiganit Sara, as its name implies, and as author himself says, the opening stanza to the work is an abstract of Patiganita. It gives the important rule and examples of the Patiganita with a slight modification, alteration, and addition here and there, and provides a short course of arithmetics and mensuration. From the study of the later part of this work, which does not have its counterpart in our incomplete manuscript of the Patiganita, we find that following two approximate formulas are Sridharacharya's own contribution to the subject. These are the some formulas that are given by the Sridharacharya, that is for calculating the area of this segment of a circle, volume of a sphere. The formula given by earlier writer are as follows. Aryabhatta formula is mentioned here. Formulas quoted by Bhaskara. Mahavira accurate formula. Sridharacharya formula is the best as it more closely approximate to the modern formula. The above mentioned formula of Sridharacharya appear in the Mahasiddhanta of Aryabhatta II, 950 AD, evidently under the influence of Sridharacharya. Indebtedness to Mahavira, these are the some stanzas that is written by the in Patiganita and second in Trisatika. Sridharaj Patiganita, having paid obeisance to the unborn God, the cause of creation, preservation and destruction of the worlds, I shall briefly state the Patiganita for the use of people. These are the contents, that is Sankalita, addition, Vyavakalita, subtraction, Pratyutpanna, multiplication, Bhagbhara, division, Varga square, Vargamula square root, Ghana cube, Ghanamula cube root. The same operation for fraction, reduction of fractions, Kala Savarna of 6 varieties, Bhaga, fraction connected by plus and minus, Prabhaga, fraction connected by of, Bhaga Bhaga, a whole number decided by a fraction, Bhagu nu Bandha, a whole number increased by a fraction or a fraction increased of itself. Bhaga Pavaha, a whole number diminished by fraction or a fraction diminished by a fraction itself. Bhagamata, a blended of two or more fraction of previous forms. Some definitions, that is Tirashika, rule of 3, Vavastha Tirashika, inverse rule of 3, Pancharashika, rule of 5, Saptarashika, rule of 7, Navarashika, rule of 9, Bhandapati Bhanda, barter of commodities, Jiva Vikra, sale of living being. 9 Vyavhars, determination, that is Mishraka, mixture, Sridi, Sris, Kshetra, plain figure, Khata, excavations, city, piles of bricks, Karakara, swamp, pieces of timber, Rasi, heaps or mounds of grain, Chaya, shadow, Sunya Tattva, the mathematics of zero. Names of notional places, that is Eka, Dasa, Sata, Sahasra, Ayuta, Laksha, Prayuta, Koti, Arbuda, Abja, Laharva, Nokharva, Mahasaroj, Shanku, Sritpati, Antya, Madhya and Pradha. Money measures. A purna is equivalent to 16 pans. A pana is equivalent to 4 kakins. A kakini is equivalent to 20 Vartkaj cowries. Sripati 1039 AD drama is equivalent to Sridhara Purna, and according to Narayana 1356 AD 12 panas equal to 1 drama and 36 drama equal to Nishka. Weight measures. Massa is equal in weights to 5 gunjas. A brucite, a weight of 16 massa is called a kharsa. A kharsa of gold is called a suvarna. 4 krasas makes a pala. Narayana mentioned one more weight, that is tula, which is equal to 100 palas. Measure of capacity. A khari equal to 16 drons. A dron is equal to 4 adakas. An adaka is equal to 4 prastha. A prastha is equal to 4 kudvas. Also, there are 3200 palas in a khari, so that 1 drona equal to 200 palas, 1 adaka equal to 50 palas, 1 prastha equal to 12.5 palas, and 1 kudva equal to 3 and 1 by 8 palas. Drona, adaka and kudvas are also found in the Vedanga Jyotisa, where an adaka is defined to be a vessel capacity of holding 50 palas of water. From Trisatikas of Sridhara and the Lilavati of Bhaskara II, 1150 AD, it appears that the khari used in Magadha was equivalent to cubic cubit. Narayana khari is equivalent to 5 cubit. Linear measures. 24 angulas, finger breadths make a hasta cubit. 4 hasta make a danda staff. 2000 of them makes a krosa. 4 krosa makes a yojan. Narayana danda is bigger than the Sridharas, being equivalent to 10 cubit, but other measures are same as those used by Sridhara. Time measure. 60 ghatis makes a Nachatmeran, a day and night. 30 of them makes a month. 12 of them makes a year. These are measures used in Patiganita. Logistic Parikarma. Addition Sankalita, rule of finding the sum of series of natural numbers. It is mentioned in the Patiganita. If we have some series of numbers, we can find out its sum. That is, if we have Sn equal to 1 plus 2 plus 3 plus and so on up to n, that is first n natural number, the sum comes to the n into n plus 1 by 2. Addition Sankalita, rule of finding the sum of series of natural numbers. So we can find out the sum of series of natural numbers. The number of terms gacha is equal to the integral square root of twice the sum of the series, which must be same as the residue left after extraction of the square root, that is n equal to integral part of square root of 2sn. These are the some examples that are mentioned in the Patiganita. What are the sum of the 1 to 10 each multiplied by 10 terms of the series whose first term and common difference are each unity? Also, from those sum quickly say the number of the term of the series. 1 to 10 multiplied by 10 means 10, 20, 30, 40, 50, 60, 70, 80 and 90 and 100. Alternative rule, we have, or the sum of the series of natural number is equal to 1/2 of this square of the numbers of terms plus the number of terms, and thus that sum multiplied by 8, then increased by 1, then reduced by its square roots, then diminished by 1, and then have is the number of terms in the series, that is Sn equal to 1 plus 2 plus 3 plus and so on up to n equal to n square plus n upon 2. and n equal to square root of 8Sn plus 1 minus 1 whole divided by 2. This is the subtraction that we have, as mentioned in the Patiganita, Vyakalita. Then we have multiplications, then operation to cipher, additive, chepa, that is 0 plus a equal to a minus 0 equal to a, 0 multiply a equal to 0, or 0 divide a equal to 0, a multiply 0 equal to 0. Division, having removed the common factor, if any, from the divisor and the dividend, divide by divisor the digit of the dividend one after another in the inverse order. Aryabhatta II, 1950 AD, gives more details of the process. Having placed the divisor underneath the last digit of the dividend, subtract the proper multiple thus obtained is the partial quotient. Next, having moved to the divisor one place to the right, divide what remains. Continue this process until all the digits of the dividend have been taken. This is the square varga, finding the rule of the square root or squaring. This rule is based on the formula a plus b whole square, that is equal to a square plus 2ab plus b square. The various examples is mentioned here. Then we have square root, vargamula, rule of finding the square root. These are some more examples that is mentioned in the Patiganita. Determination Vyavhara, here we have the simple interest, allegation, partnership, purchase and sale, meeting of two travelers, wages and payments, the cistern problem, wages paid from the commodities, combination of saviors, certain special type of problems, cube, ghana, cube root, ghana mula, operation of fractions, reduction of fractions, kala savarna, rule of 3, trish rashika, inverse rule of 3, rule of 5, 7, 9, vyavastha rashika, pancha sapta nava rashika, barter of commodities, bhanda pratibhanda, sale of living being. Determination Vyavhar, determination pertaining to series Sredi Vyavhar, Mishra ka Vyavhar, series of arithmetic progression, geometrical interpretation, series of arithmetical progression, symbolical interpretation, miscellaneous problems on series in arithmetic progression, series of squares and cubes, etc. of the terms of arithmetic series. Determination pertaining to the plane figure, Kshetra Vyavhar, introduction, area of the quadrilateral with equal altitude and the triangle, area of the quadrilateral with unequal altitudes. These are the reference that I have taken. That is Gupta 2008, Jhansi 2002. There is some more bibliography. With that, I thanks to everyone. Namaskar, Dhanyavad.